Chapter probability distribution. The first section, which is from chapter 5, is probability distribution. So let's go here. Some of the things we're going to discuss in this section is, random variables, probability distribution, probability histogram, and mean, standard deviation, variance. They are parameters for the probability distribution. And when we are going to have significantly low or significantly high outcomes, these are the things we're going to discuss in this section. So some of the basic concepts of probability distribution, like random variable is a variable. Typically we use this letter x for random variable that has a single numerical value determined by chance for each outcome of a process. So we are talking about some event, and if those event outcomes can be expressed as a number, then those number are called random variable. Think about this. Let's say we are talking about probability of having a baby girl, in first birth. There are two different possibilities. Either baby would be female or male, boy or girl. So the probability could be, let's say we are just talking about one birth, then probability of finding the female could be 0.5 or very approximately equal to the 0.5. But if we try to find out exact what's going on, let's say in two birth, first time it could be female, second time it could be female or male. First time it could be male, and second time it could be again female and male. So altogether, if you look at the four different possibility, there could be in both birth it could be female female, female male, male female, and then eventually male male. So out of two birth, those events, the chances of having, let's say, 0 female out of here, we can express those chances. How many females? Let's say x represents number of females in two birth. Let's say 0 females or 1 females or 2 females. Okay, these are the three possibility, and these three possibility are called random variable. Okay, so that's the random variable. That's the outcome of this four different as you can see, four different options available. But you could have 0 female like this, you could have 1 female like both of them, and you could have 2 female like this. So we can divide this kind of events into as a random variable like this. So x is number of females in two birth, and their probability, we can represent that by p of x, which is probability of having 0 female is, you can find out that probability, or maybe you have given that probability, so we can write down that thing here. So as you can see here, it's out of 4, the probability of having 0 female is there, it's 1 out of 4, so which is 0.25. I can write down 0.25. 1 female, it's 0.5, because there are two possibilities where you have 1 female, and then 2 female, it's again 1 out of 4, so that's a 0.25. So in this example, the value of x, which is a numerical value, that's a random variable. Probability distribution is a description that gives the probability for each value of the random variable. It is often expressed in the format of table, formula, or graph. The example I was giving you here, this table represents, the first column of this table represents a random variable, and the second column represents probability for each of these different random variable. This column, the second column, gives you distribution of probability. That's what it is called, probability distribution. How probability is distributed in all these three different situations. That's called probability distribution. Okay. Discrete random variable. So it's a random variable, but now the outcome has a collection of values that is finite or countable. So you can count your outcome. So if you go back to this very same example here, There are three variables, 0, 1, and 2. So this is discrete because it's finite, it's a countable. So it has to be finite or countable. Sometimes it could be infinitely many, but if you can count it, that's a discrete random variable. If there are infinitely many values, the number of value is countable if it is possible to count them individually, such as the number of tosses of a coin before getting heads. So, whenever you have outcome which you can count, possibly, that's called discrete random variable. There is another random variable called continuous, where counting your outcomes should be infinite for sure, and you cannot count them. So has infinitely many values, and then collection of value is not countable. Example, you are trying to measure temperature, body temperature. So we know that body temperature could be somewhere between 97 to 105, 6. Let's say we have that number. I'm just giving you a hypothetical, not a hypothetical, but just one example. It's not perfect number I'm giving you. So in between 97 to 105 body temperature, there are infinitely many numbers. You cannot count them actually. That's why this type of variable is called continuous random variable. Okay, so now there are requirement to have probability distribution, and that is I'm going to give you those requirements. Every probability distribution must satisfy each of the following three requirements. So one is, there is a numerical random variable x. Make sure that the random variable should be numerical, not categorical. To have probability distribution, your random variable should be numerical, and its number values are associated with corresponding probabilities. That's the one requirement. When you try to add all the probabilities given for the random variable, it has to be 1, where x assume all possible values. If you go back here in this example I gave you, if you try to add this column, then it has to be 1 to be probability distribution. Okay, so in calculation from the real life data, 0.999 or 1.001 are acceptable because they result from some rounding error. So whenever you see 0.999 or 1.001 as a sum of the probabilities, then that is okay because it's coming from human rounding error. So the probability p of x should be always in between 0 and 1, inclusive 0 and 1. So these are the three requirements you must see when you are playing with the probability distribution requirement. So let me just go to one example here. The first one from this section. Here you have given data. Here, this is the data. And now we need to find out, okay, this is the data. This table lists probabilities for the corresponding number of unlicensed software packages. Okay, what is the random variable? So first column gives you 0 unlicensed software package. The probability of having 0 unlicensed package is 0.215. Probability of having 1 unlicensed software package is 0.375. Probability of having 2 unlicensed packages, again 0.375, and 3 is 0.215. So this is the data we have given, and from this data we need to find out what is the random variable. As you can see that always the value of x, the first column here in this case is your random variable. So the random variable is x. So only the choices in C and D you have the random variable is x, which is the number of unlicensed software packages. The possible values of x are 0, 1, 2, 3. The values of the random variable x are not numerical. So this is not right because it has to be numerical. So the answer should be D. If you read the option D, the random variable is x, which is the number of unlicensed software packages. The possible values are 0, 1, 2, 3, and the values of the random variable are always numerical. Okay, so that's how we can find out either our variable is random or not. So let's go to next problem. Okay, this one. Okay, so again we have given here, data is given here. College students are randomly selected and arranged in groups of 3. So there are 3, each group there are 3 students. The random variable X is the number in group who say that they take one or more online courses. So, in those group, 0 of them are taking online course is the probability of getting that number is 0.102 from the data we collected or whoever collected. Determine whether a probability distribution is given. If a probability distribution is given, find its mean, standard deviation. We're going to talk about that, how we are going to find it. But the first question I want you to look at here is this a probability distribution? And for that, you need these 3 requirements. The random variable should be numerical, and some of the probability given you have should be 1. And then the probability for individual event individual outcomes should be in between 0 and 1. So let's check that one. So if you look at on the first column, this is the random variable and they are given in numerical nature, so it's a random variable, and the probability of this variable on the second column, it's less in between 0 to 1. Now we just have to add this number. If you add this all this probability, it would be I'm adding this, it's what is that, sorry, okay, this is where you have, okay, if you add this number here, okay, if I add this number, which is 0.102 plus 0.355 plus 0.4 plus 0.143, if you add this number, it's 1. So this is it's a probability distribution. Does the table show a probability distribution? The answer is yes. So there is only one answer. Yes, the table shows a probability distribution. Good job. Okay, so to answer the next question, like how to find the mean and mean and the standard deviation, we have to go further. But before that, I would like to talk about probability histogram for the probability distribution. So in this example, as you can see, I'm taking the same example. Out of 2 births, the probability of having 0 female, 1 female, and 2 female. If you plot that data here with the corresponding probability on the y-axis and the number of females on the x-axis, this represents probability histogram. So a probability histogram is similar to a relative frequency histogram, but the vertical scale shows probability instead of relative frequency based on actual sample results. Okay. Now, sometime we can also express our probability distribution using some formula. For example, for the previous example, we can express probability of having 0, 1, or 2 female can be calculated by using this formula. Sometime we might have formula for calculating probability distribution. Okay, so since for the probability distribution, we actually take whole population instead of sample. So remember that with the probability distribution, we have a description of population instead of sample. So the values of the mean, standard deviation, and variance are parameter, not statistics. So they are not coming from sample. The mean, variance, and standard deviation of discrete probability distribution can be found by using following formula. So that's the formula we're going to look at here. So to calculate the mean, you have to find out the multiplication of x and the probability, the random variable and its corresponding probability, and find the sum. For calculating variance, there are 2 different ways to calculate it. Either you can use this formula or this formula, it's up to you. To calculate using the first formula, just first of all find the difference between x and mu and square it, and then times it by the probability, given probability, and just add them all. That gives you the variance. Or you can just multiply the square of the random variable with corresponding probability and find the sum, and then eventually subtract mu square from that sum. That also gives you variance. And then from the variance, we can find the standard deviation using square root of the variance. So these are the formula to calculate mean and standard deviation and variance. So let's go back to the problem again. So here we need to find out the mean and standard deviation, right? So what is that? Find the mean. So how do you find the mean? So remember, finding the mean is this formula. So there are two different ways you can calculate this mean and standard deviation. The first way I'm going to use is, I'm going to use Excel and I'm going to compute this value manually. So that's the first way we can do. Okay. So as you can see, if you look at the formula here, we need to multiply x and probability. So this is the first column is x, second column is its corresponding probability distribution. So we need to multiply that, and I can just multiply this column times it by this column. So that gives me the multiplication, and I'm going to do the same thing for next row, and next row. So I'm just going to scroll it down. So now Excel is going to calculate that for me. So mu or mean is just sum of all these values. So I'm going to use equal sign and use sum command, and starting from this row, and I will go up to here. So that gives me the mean, which is 1.584. Okay, so that's the mean for this problem. And for finding the variance, as you can see here, there are two different approaches. So I'm going to use this approach, which is square the variable, times it by probability, and subtract the mu square. So this is my square the variable, which is x squared. Okay, which can be found by just selecting this one and squaring command, and then I'm just going to scroll it down. So that is x squared for each of them, times it by corresponding p of x. So next column, I'm going to times it by corresponding p of x, which is this one. So this column is x times p of x. Okay, so if I scroll it down, it gives me x squared times p of x. Sorry, it's x squared times p of x. So now we need to sum it. I'm trying to use this last formula here, which is sum from first column to this column number 5 here. So that's the sum, this first part. Remember, I'm using this formula. So that is this one, x squared times px. Now I have to subtract mu square, which is from this value, I'm subtracting square of this value, which is mu square. And now, because it's a variance, I need to find out the standard deviation. The standard deviation is always this value, to the power 0.5. That's a square root of variance. So in this, for this problem, 1.584 is my mean, 0.85612 is my standard deviation, 0.732944 is my variance. So we can calculate this value using manually like this. And there is another way I'm going to discuss here using your TI 8384 calculator as well. So for that, first of all, go to stat here. What is that? Stat, and go to number 1, which is edit. And now in this here you can save your data. So L1 stands for the first column, L2 stands for the second column. I already use this calculator before to save some data, so it's already there, but you can type it manually. 0, 1, 2, and then up to 3. There is no 4 and there is no 5, so I'm going to just delete those 4 and 5. So now I will go to the next column, which is first one is 0.102. I have to enter that 0.355. The third one is 0.4, and fourth one is 0.143, and there is no fifth one and sixth one. So this is the same data here. Okay, this is the same data. I'm trying to calculate this mean and standard deviation by using this TI-83 calculator. So first of all, I can go to the stat, I can go to the calculation here, and number 1 is using the one variable. If I enter that, it asks me my data. So I'm using the data L1 and L2. So for that, hit second, and then 1, that means L1, comma, again second, and L2. So this command takes my those two data and it gives me mean and standard deviation I'm looking for. This X bar is actually mean of the population, which is 1.584, which is same as we found using the actual, using the manual way. And this is standard deviation, as you can see here, 0.8561214867. That is the same standard deviation we got from this Excel set using manually. But you don't have to do it manually if you don't feel comfortable. You are always allowed to use this TI-8384 calculator. Okay, so now let's check our answer, if that is right answer or not. So our answer is, for the mean, the answer is 1 point, rounded to the 1 decimal place. So it's a 1.1 point, what is that? 6, 1.6. Right? If you round it to the 1 decimal place, it should be 1.6. And for the standard deviation, as you can see here, it's a sigma x, which is point, round to the 1 decimal place. So it's a 0.9. That's a 1 decimal place. Right, it's a 0.9. Okay, so that's how we can find out mean and standard deviation using remember, if you try to use this TI-8384 calculator, there is no variance, but you can always find the variance by squaring this value of sigma x. Okay, so that's the next problem. So let's go to the next problem and let's see what we have asked here. Okay, again, and there is a data. The data is given here, and now we need to calculate the mean and standard deviation. That's this very same problem. You can either use Excel, or you can use the way we just discussed, use TI-8384 calculator. Just you need to update your table here, and then it will give you the answer. So this time I'm just going to use TI-83 calculator here. So one more time, just go to stat and edit. So here, this is different set of data, so you have to update this data here. There are data from 0 to 8, so I'm going to update this 0, 1, 2, 3, and then 3 is fine, and then 4, 5, 6, 7, 8. So now go to data for the second column, which is start from the first one, which is 0.003, 0.032, 0.103, 0.224, 0.281, and 0.215, 0.104, 0.033, 0.005. Oh, what is that? Okay, let me just go back here. 0.003, what is that? Here we go. 0.003, 0.032, 0.103, 0.224, 0.281, and now this is 0.215 and 0.104 and 0.033. Finally, it's 0.005. So this is our data. We can go to the stat, we can go to the calculation here, calc, second item, and one variable enter, and okay, one more time, let's clear it. Stat, calc, 1, and we are using data from first L1, and just use second and 2. So it's using data from L1 and L2, and if you enter it, it gives you the mean, which is 4.004. So what is the mean? 4.004, but you have to round it to the 1 decimal place, so it's a 4.0 or 4. That's the mean. And standard deviation, as you can see, it's from sigma x, which is 1.407. If you round it to the one decimal place, it would be 1.4. So 1.4. Okay, so that's how you can find out the mean and standard deviation. And then variance. There is one terminology called expected value. The expected value of a discrete random variable x is denoted by e, and it is the mean value of the outcome. So this is not the mean, it's a mean value of the outcomes. So you look at the different possibility and we try to find out mean of all those different possibility. Okay, so we can also write down this as a expected value is mu, and e can also be found by evaluating this mean. Okay, we're going to see one example here, but before that I would like to give you the this information here. Whenever you try to use this data and calculate this value, mean and standard deviation or variance, we can always find out the range rule of thumb for identifying significant values. Significantly low, which is any value less than mu minus 2 sigma. Significantly high, which is any value greater than mu plus 2 sigma. And values not significant are between mu minus 2 sigma to mu plus 2 sigma. Okay, so anything, if you are playing with some random variable, if the probability of getting that variable x or more is less than 5% or less than 0.05, and that is under this shown significantly high number of success. If that is probability of getting x or fewer is less than 0.05, that is significantly low number of success. So whenever we try to find out this thing, we can always this information. Okay. The real event rule for inferential statistics: if under a given assumption the probability of a particular outcome is very small, and then outcome occurs significantly less than or significantly greater than what we expect with that assumption, we conclude that the assumption is probably not correct. Okay, so one more time, expected value is its average of mean of all the outcomes, and which also can be calculated by using this formula. Now I'm going to use one example. Let's say this one. If okay, in a state's lottery, you can bet $4 by selecting 3 digits, each between 0 and 9. So from 0 to 9 there are 10 numbers, and you can only win if you select 3 correct digits. So how many different selections are possible? Remember, in 3 digit, first number can be selected in 10 different ways because there are 10 different numbers. And similarly, because you can repeat the numbers, so second digit can be selected by using 10 different ways, and third digit can be selected by using 10 different ways. So number of possible okay, let me just so there are 3 digit. Let's say digit 1, digit 2, and digit 3. This one can be selected by using 10 different ways, this one 10 different ways, this one 10 different ways. So altogether there are 1,000 different possibility. Okay, so how many different selection are possible? 1,000. Okay, what is the probability of winning? So out of those 1,000, only one of them is going to win, so the probability of winning is 1 out of 1,000. And now if you win, what is your net profit? So if you win, according to the problem, you are going to get 500, but out of this 500 you already paid $4 for the ticket price, so it would be 500 minus 4, which is 496. Okay, now this is the most important question here. Find the expected value for a $4 bet. So remember, the expected value means it's the mean of all the different outcomes. So there are 2 different outcomes, winning and losing. Okay, so how do you find winning and losing? So if you win, okay, then you make $496, and if you lose $5 $4. So losing means negative, you are losing the money, negative, so that's why it's -4. If you win, you win $496. So but what is the probability of winning? Probability of winning is 1 out of 1000. That's what we found. But probability of losing is, it's a 999 out of 1000, because there are 999 possibility. If you get those 3 digits from this list, then you are going to lose. So remember, this thing here, this is the random variable x, and this thing here, it's your probability for corresponding x. So when you try to find out the expected value is so x times px, it's a sum of x times px. So there are only 2 possibilities, so we can say, hey, expected value is -4 times 999 over 1000 plus 496 times 1 over 1000. So that is how we can find out the expected value. We are finding basically the way we found the mean. We are finding the same thing, but it's giving you 2 different outcomes. First outcome gives you this possibility, second outcomes gives you this possibility. First outcome gives you this value, second outcome gives you this value. If you add them, so I'm going to use calculator here. It's a -4 times 999, so it's a negative, let me clear it, -4 times 999, enter, that's -3996 plus 496. Both of them have 1000 on the denominator, so I can just add them first and divide it by 1000. So that gives me -3.5. So the answer for this is, expectation is -3.5. So let me just check the answer. What does it mean? It means when you buy $4 ticket, your expectation from each buying is losing $3.5. Every single time you are buying, your expectation is you're losing $3.5. Okay, let's go to another question here, or scenario. If you bet $4 on a certain casino game, the expected value is -1.5 cents. Which bet is better? So look at here. If you go to the casino and if you are bet $4, then your expectation is on each bet you are losing 1.5 cents. But if you buy that ticket, then you are losing $3.5. So it looks like this bet is better than this one. Okay, in this scenario, I'm not saying it happens actually, in real life, but just for this scenario, the possibility is, the casino game is better bet because it has a larger expected value. So expected value always gives you the different perspective using the probability. Okay.